All right, let's get started with 5.5. Last section of chapter 5, multiple angle and product to sum formulas. So the last set of formulas we're going to need here in chapter 5. So in this section, a couple things going on. First thing, so 4 different sections we're going to look at here. First, multiple angles, all right, such as sine 5x or cosine 2x, something like that. Second category, we're going to have squares, so it's like sine squared. The third one, we have the half angles, so something like sine of x over 2. And the fourth one has products when we multiply them together. All right, so there are 4 different sections that we're going to add to our trig identity sheet. Grab that note sheet that you've been adding formulas to all of chapter 5. And the first one for this section is our double angle formulas. So we've got 3 of them: sine of 2u, tan of 2u, and cos of 2u. Okay, if we ever had to do like secant, we could flip it over and use the cos 2u formula. All right, and you'll notice that cosine has 3 different options because it's cosine squared minus sine squared. And you'll remember that cosine squared is the same as 1 minus sine squared, or sine squared is the same as 1 minus cosine. So cosine squared. So if we substitute in for either of these, we can have just cosine squared or just sine squared. They both work. All right, so let's take a look at our first example. I've got the formula up there so we can look at it. 2 cos x plus sine of 2x. All right, so our job here is to replace this using our new formula here. So let's write it out. 2 cos x plus substitution 2 sine x cos x equals 0. And now we notice that there's a 2 cos in both terms. Forgot my x. We can factor that out. 2 cos x sine x. I'm sorry, I made the mistake that I always tell everybody not to make. We need our placeholder for the first term. 1 plus sine x equals 0. And so now we can solve 2 cos x equals 0, or sine x equals -1. And so we can divide by 2 here and just still cos x equals 0. On the unit circle, where are the x values equal to 0? That's going to be at pi over 2 and at 3 pi over 2. And where are the y values equal to -1? That's at 3 pi over 2. So our solution on this one is, obviously this is a repeat, so we don't need to say it twice. But we do need to say every possible combination. So pi over 2 plus 2 pi n, 3 pi over 2 plus 2 pi n. Those are our solutions. Your turn. Problem 19. All right. So we're going to use a double angle formula here, and we can forget about the sketching. Remember, in chapter 5, we're not going to be going over anything graphically. So when the textbook is asking for the sketches, I'm not going to be asking you for those for this section. So double angle here, we've got 4 cosine squared minus 2. Y equals, I'm going to pull a 2 out of this. So we've got cosine squared x minus 1. And if I look down here, 2, oops, I forgot my 2. 4 divided by 2 is not 1, it's 2. 2 cosine squared x minus 1 turns into cosine of 2x. All right, so we've rewritten this as y equals 2 cosine of 2x. All right, your job, do something similar on 33. All right, one more with the double angle formula. Might be 2 more. Let's see. Yep, 2 more with the double angle. Here we go. All right, so use the following. We want sine of 2 theta, cos of 2 theta, and tan of 2 theta. We know what cosine is here. So the first thing we need to figure out is all of our other options. We need sine and we need tangent. So we can plug into all of these formulas. And we know that we're in quadrant 4 here. So in quadrant 4, if I drew myself a triangle, and I've got a 5 and a 13 with my theta in here, I know this is going to be negative 12. That's a Pythagorean triple. If you use the Pythagorean formula, you get negative 12. Well, you get 12. Since we're in quadrant 4, it's got to be a negative. So now I know that sine theta, opposite over hypotenuse, 12 over 13, negative. Tangent, opposite over adjacent. All right, so let's just plug things in now. Sine of 2 theta is going to be 2 sine theta cos theta. I'm just going to grab them and plug them in. Sine is negative 12 over 13. Cosine is 5 over 13. And 12 times 5 is 60, times 2 is 120, so negative 120 over 169. If we did cosine of 2u, sorry, 2 theta. In this problem we're using theta. And on this one it really doesn't matter which one we're going to use. We could use the first, second, or third one. And so let's just go ahead and use the first one. 5 over 13 squared minus negative 12 over 13 squared. So we've got 25 minus 144 all over 169. And so we end up with, what is that, 119? Negative 119 over 169. And then lastly, we could do tan, sneak it in over here. Tan theta is 2 tan theta. So 2. The tangent is negative 12 over 5. All over 1 minus negative 12 over 5 squared. And so our final answer here is going, well, let's see, we might need to do another step. We've got 24 over 5. We've got 1 minus, remember the negative here is going to go away when we square it, 144 over 25. All right, so let's clean this up. Negative 24 over 5. I'm going to flip it, so we do multiply the reciprocal. It's going to be 25 over 20. This one would be 25 over 25 minus 144 is going to be negative 119 again. That's a 1, that's a 5. And so we'll have 24 times 5 is negative 120 over negative 119. So we'll cancel and just have 120 over 119. All right, so just keep track of all your fractions and you're going to be okay on problem 37. All right, so just one note here before we move on. The double angle formulas doesn't just have to be 2 theta, okay? If we did the sine of 4 theta, the formula still works, we just double it. Instead of sine 2 theta equals 2 sine theta cosine theta, we can make it 4, 2, and 2. We can make it 6, 3, and 3. We can make it 8, 4, and 4. Perfectly fine. You can keep doubling with your double angles as long as this is twice these two. Okay? All right, so let's move on and see about triple angle. So to find a triple angle, we're going to start by using our double angles. And so if we wanted to figure out what is sine of 3x, what we could do is think about that as sine of 2x plus x, right? And so from there, we could start splitting things up. All right, so on this one, we're going to use from the last chapter where we had the sine of u plus v, we know that that is sine u cos v minus cos u sine v. So if you have to go look that up, go ahead and do that. This is in 5-4. Okay? All right, and so let's clean up from here. Sine of 2x. We're going to go use this one now. This is 2, just this part, 2 sine x cos x, and then we'll bring down the other cos x, minus, all right, just this part, cos of 2x, is, since we're timesing by a sine, let's go ahead and use the one that just has sine in it. Well, let's see. Yeah, that's it. I think that's a good idea. 1 minus 2 sine squared x sine x. Okay. All right, so now we've got 2 sine x cosine squared x minus sine x plus 2 sine cubed x. All right, and so we've got, let me rewrite these in order, 2 sine cubed plus 2 sine squared cos squared minus 2 sine x. Okay, just moving them down in order. And so then, lastly, to finish this thing up, we know that cosine squared, we can simplify this a little bit because we know that come back, pen. There it is. Cosine squared is 1 minus sine squared. So that's going to be 2 sine squared x minus 2, just distributing, sine to the 4th x. So now we've got 2 sine cubed x plus, and then bring down the minus 2 sine x. Alright, so we can clean this all the way up and put it in order. So a lot going on here, just moving things around, but we have them all in terms of sine. Okay? Alright, so your job here on this one, see if you can verify that this is true. Okay? I would start with the right side, clean up the right side, see if you can make it cos of 4 alpha. All right, so we're moving on to the third section here, power reducing. We can take a squared and break it down to a non-squared with these 3 formulas. So take a second, get those in your notes, and then let's try example 5. So let's rewrite sine to the 4th x as the sum of first powers of the cosines of multiple angles. Okay, so what that means is we're not going to stop until we have cosines only, okay, and we can only have x to the 1st. No squareds, cubes, or anything like that. All right, so sine to the 4th. I'm going to rewrite that. Since I know about squared, I'm going to rewrite this as sine squared x squared. Right? Squared squared gets me to the 4th. So what I have here is 1 minus cosine of 2x, and this is going to be all over 2. And then this whole thing is getting squared. So we just took this and replaced it in with our formula. All right, and now we have to square it. So 1 minus 2 cos 2x plus cosine 2 squared is going to be 4x. Okay, on number 5 here. And this whole thing is going to get divided by 4, okay? And so now let's see what we've got here. We do have formulas for, hold on one second. Sorry about that. I was just checking on one thing. I made one mistake right here. When we FOIL this, this is going to be cosine of 2x, the whole thing being squared. And so now we're going to need to go into this formula for just this part, because we can't stop until we get rid of all of the exponents. So we still have 1 minus 2 cos 2x, and then plus, it's going to have a little fraction in here, 1 plus cos, we double it, so it was 2, now it's going to be 4, all over 2, all over 4. And so if we get ourselves common denominators here, we're going to have 1 over 8 minus 2 over 4 turns into 4 cos 2x all over 8. And then we're going to have plus 1 plus cos 4x all over 8. And we could put this whole thing together by pulling the 8 out front. The 1/8, sorry. And let's see what we've got here. We've got a 1 plus a 1. I think that's right. Yep. Equals 2. Minus 4 cos 2x plus cos. Let me rewrite it so we squeeze it in here. 1/8. 1 plus 1 is 2 minus 4 cos 2x plus cos 4x. And I think, let's see. Oh, there's my mistake. When I doubled it should have been a 2. So this will be a 3. All over, just 1. Sorry about that. That's a little convoluted, but there's our steps all the way through. We're substituting all three, just both of these. Sine squared and cosine squared. Didn't have to deal with tan squared, right? So when we squared, here's the important parts, and that I stumbled on a little bit. Let's see if we can clarify this. First, we're going to FOIL, right? We get all three terms. And when we FOIL this last part, cos 2x times cos 2x is going to be cos 2x squared. So when we substitute that back in, we're going to get 1 plus cos 4x over 2. And then the last part that I don't think I explained very clearly was we're going to get the common denominator. 1 over 4 is the same as 2 over 8, right? 2 over 4 is the same as 4 over 8. And then 2 and 4 combined give us this 8 denominator here. This numerator stays the same. All right, from there I pulled the 1/8 out front. This remains in the parentheses. All right, so do your best on 43 to get cos to the 4th x all the way down. So all we have left are cosines to the first. All right, so lastly, we're going to use our half angle formulas. We've got these three here. And the sines of u over 2, this last one here, depends on which quadrant we're in. Because remember, when we do square root, it's plus or minus. We're not going to say both answers. We're going to ask ourselves, all right, which quadrant are we in? If we're in quadrant 4 and we're doing sine, we would have to do a negative. All right, because in quadrant 4, we're going down. So we're going to have negatives when we're talking about sine values. All right, so let's try this. What's the sine of 105? All right, so 105 is not on our unit circle. But if we doubled it, 210 is on our unit circle. 210 divided by 2 is the same thing as 105. So that equals the square root of 1 minus, I'm going right here, the cosine of u, so the number on top of 210, all over 2. All right. 210 is right here. The cosine of that is going to be negative root 3 over 2, all over 2. So this is 1 plus root 3 over 2, all over 2. All right, so let's be careful with our fractions here. 2 over 2 is 4, so we're going to need 4 as our denominator. This is going to be a 2 plus root 3. And the square root of 4, the denominator can get cleaned up. So it's 2 plus root 3 underneath the square root. You're allowed to have square roots of square roots, and you're going to see that here for the first time, all over 2. Now the question is this going to be a positive or a negative? All right. And so in this one, when we look, if we flip back here, or we look at this, the sines of u over 2 depends on which quadrant u over 2 lies. So 105, back at the beginning. Okay. 105 degrees is over here in quadrant 2. 105 degrees, if we asked about the sine value, we're going up. That's a positive. So positive is what we want here. Right? If it was cosine, we'd say negative, because if it was cosine, we'd be going to the left and have a negative x value. All right, your turn with 59. All right, so from here on out, I'm not going to do the examples for the rest of them Okay, you can stop after 6 if you like. The rest of them are just more examples. Okay, don't need you to spend all of your time doing that, going through all of these. I will put up the solutions here. You can check the examples. These are all in the textbooks. Okay, but I will put the examples or the answers up for the try now problems that this is in the way of. Okay, so 77. Next one for you to try. All right, so product to sum, we do need to take a look at this one. All right, didn't need to look at this one, just another example. But new formulas here, product to sum formulas. All right, so we have all these down. Pause this for a second and get them. And let's use them. Cos 5x sine 4x. All right, so cos then sine is this formula. We're just going to plug it in. 1/2 sine of u plus v minus sine of u minus v. And we've got 1/2 sine of 9x minus sine of x. Okay? And so on this one, we're going to leave it just like that. Right? Nothing more you can do. 85. Try the same thing. Okay, and then lastly here for these, we have sum to product formulas go in the other direction. If we're adding or subtracting, we can put them together as a product. So let's do cos 195 plus cos 105, cos u plus cos v right here. So we're going to do 2 cos, add them together, 195 plus 105 over 2 times the cos of, subtract them, 195 minus 105 all over 2. All right, so we've got 2 times the cosine of, if we add them together, we get 300. Divide it in 2, we get 150 times the cosine of. If you subtract them, you get 100. And is that true? Let's see. Nope, you get 90, sorry. Divided by 2 is 45. And luckily, both of those things are on our unit circle. 150 degrees is right there. The cosine of that is negative root 3 over 2. And the cosine of 45 is positive root 2 over 2. So let's see what we got here. We've got 2 root 6 with a negative in front all over 4. And so we're going to have negative root 6 all over 2 as our final answer. All right, so use this on problem 99. Oh, there's the answer. All right, so let's use this to solve in example 10. Sine 5x plus sine of 3x equals 0. In fact, 10 and 11 are just repeats of the same one. All right, so you can take a look at those in the book if you need to. Okay. But 103, just another example. Try that if you have time. And I'll pause here and then put the solution up. And then I'll do the same thing with 11. So a lot of examples in this problem. I don't think we need to spend our time doing all of them, as long as we have all the formulas down and have tried at least one problem with each of the formulas. Okay, so a lot of formulas in this chapter. Make sure you have them all down in your notes. All right, we'll go over all these that you had questions with, and good luck with getting all these problems done.